In today's episode, we are going to talk about the basics. The introduction has been split into two parts. In the first part, we try to answer to the question, what is the framework? Plus, we will start creating our first application. We will create the simple REST web service that will operate on the book's resources. So, what is the framework? Framework is a set of tools, libraries, and conventions that enables developers to create applications more quickly and efficiently. What is the difference between framework and the library? As I said, framework contains a set of libraries, so a framework is more complete solution. Framework plus your business code creates whole application. Framework like the Spring Framework can contain very usable tools like dependency injection container, which is the base of the Spring Framework, plus I described it in the previous videos. Check it out. Configuration tools, authorization mechanisms, and much more. What Spring Framework is made of? On the diagram, you can see the layers and the components. Have a look at the core container. As I said, the dependency injection layer is commonly delivered with the frameworks. In case of Spring Framework, is most important one. Core containers consist of beans, core, context, and SPL. We will talk about the beans, core, and context later, but SPL, which stands for a Spring Expression Language, is a quite big piece of the information which we'll discuss in the another episode. The another layer is the data access integration. By using this layer, developer doesn't need to talk explicitly with the database. You don't need to know how to handle and keep the connection to the MySQL database, for instance. You don't need to use the set of libraries that allows you to talk with specific database engine. All of this is being resolved in this layer, which is covering the database type and provides kind of the abstraction, transaction handling, and much more. The third one is web layer. Here the whole logic web related is included. HTTP traffic handling, like the request and responses, MVC support, interceptors, filters, and web security. All of it is being included in this layer. The test layer provides us tools, conventions, and practices to create reliable tests for our Spring-based application. Last but not least, AOP, aspects, and instrumentation as the layer that help us to work with the aspect-oriented programming. It's a huge topic which is going to be covered in the channel as the another episode, but in the nutshell, aspects are like assistants that helps us to perform some side job tasks. What is the difference between Spring and Spring Boot? Spring Framework is a set of tools. It means that if you want to create the application, you need to take every single piece of the Spring Framework and combine all together with your business code in order to have it up and running. Spring Boot, on the other hand, automates it and provides a more convenient way to create the application. It provides auto-configuration, which eliminates most of the manual configuration you would need to do on your own using the Spring Framework without the Spring Boot. Embedded servers. Normally, Spring Framework doesn't provide you the server. In such a case, you need to deploy the application into some external server like the JBoss or Wildfly, which you need to maintain. In case of the Spring Boot, it's embedded and you can use it on the local environment, but also on the production servers. Production-ready features such as metrics and health checks. And in this case, no code generation and no requirement for the XML configuration. Alright. What do you want to create today? In 2 parts video, I want to go with you through the application development process, and the results should be up and running simple CRUD application. In general, we are going to serve some REST endpoint, which is going to be handled by the controller. Controller is going to pass the business execution to the service, which is using repository and the entity, the part of the data layer. In this first part, we are going to do half of the job, but don't worry, at the end we will have the running application. By splitting the application this way, we are solving somehow MVC pattern, Model View Controller. This allows us to organize the code in the convenient way and introduce the responsibility boundaries. Time to initialize the project. By using the official Spring Online initializer, let's generate default application groundwork. For today's purposes, we are going to leave the configuration as is and simply generate. I have the zip file, unarchive it, and run the IntelliJ. Let's have a look. What do we have? The entry point is the build.gradle file. It's the configuration file of build automation tool build.gradle, which we are using in this application. It's being used in the industry widely as well. Build.gradle file describes the dependencies, plugins, metadata, and much more information about the repository. We need to focus on the dependency section here. As I said earlier, we will use the data and the web layer in today's example. I said also that Spring Boot provides auto-configuration for many trivial tasks. We need to have 3 dependencies here. One for data layer, one for web layer, and one for a database we want to use. In this specific case, we'll use the H2 database, which is temporary in the memory application. Let's define it. Spring Boot Starter Web, Spring Boot Starter Data JPA, and H2 database. By the way, I made a mistake here. It should become H2 database. Build file ready. What's next? We need to have data access layer, meaning entity and repository. Let's define entity. Entity is an object representation of the data in the database. So every entry in the table will be an entity instance in the code. As I said, we are describing book, so we need to have the ID for sure, title and author for our purposes. How to have an access to book table and to book entity instance in the code. We need to have something that will represent the communication between our application and the database. It's called a repository. In Spring, the simplest repository is the interface that extends CRUD repository from the Spring data package. CRUD repository accepts 2 generic types. First of them stands for the entity type, and the second one for the type of the identifier. We added ID field in the entity, and it has long type, so we use it in here. The last thing is to annotate the interface as the repository. It tells to Spring 2 things. The first one, it will be available in the dependency injection container, and the second one, it will be handled by the Spring data access layer mechanisms, meaning we will talk to the database using the repository. There is no need for any method declaration because we are going to inherit generic methods from the CRUD repository. We have an entity and a repository, means we have communication with the database covered. What's next? We need to communicate somehow between the end user and the application. Here we will integrate the Spring Web layer using controller functionality. Let's create it. Let's create BookController. It's a class that consists of methods which represent the web endpoints. In our case, REST resources. That's why we need to annotate the class as the REST controller. If you are not familiar with the REST term, I put the link to another episode in the video description. Anyway, in the meantime, we added the request mapping annotation, which, used on the class, will specify the prefix for endpoint for the whole controller. In this case, every method will be served in the /books prefix. Once we did this, let's work on the controller body. First thing is that we need to have some base to work on. Let's use the book repository we created a minute ago. By creating constructor and defining book repository as the parameter, we tell Spring to inject book repository instance on the controller instance creation stage. If we have just one constructor, it's not needed to add the autowire annotation, but for the sake of this tutorial we add it. Now, once BookController is being called, we operate in the scope of the instance of this class. We know that the book repository property will be available. Time to implement the REST resources. We need to handle get, post, put, and delete request types. Let's do the get of the lists of the books first. Let's define the getBooks method that will return result for the find all on the repository instance. As the result type, we'll use the iterable from the books. Only one thing missing here is the annotation that will say to Spring this method should be available under some address. GetMapping is the annotation we need. By defining the /value, we know that by using request mapping from the class annotation, this method will be available for the end user under the address localhost/books. Alright, we have the method for getting the list of the books, but for a proper REST endpoint, we need to have the endpoint for getting the single book by ID. Let's add it. We're creating the new method called findBookById, which will accept some argument. Then, on the repository instance, we are calling findById, which we didn't define in the repository itself, but it's being inherited from the CRUD repository. In case of no result, we want to throw an exception. Again, by adding getMapping, we define the address for the endpoint, which is localhost/book/id. But one thing is missing here, I believe. If we want to get ID from the address, we need to annotate ID argument with the path variable annotation. It will tell Spring that the ID is being placed as the variable in the path. We know how to get the list of the books and the single book, but for now we don't have any entry at all. That's why we need to create another endpoint. In REST terminology, post request stands for creating resource. So let's define method createBook, which accepts book argument and calls repository method save. In order to have this method available for post request type, we need to use another annotation, post mapping, with the value of /, which means that if we call post request type to localhost/books/, we will be able to create the book in the database. But we need to tell to Spring that the book argument should be get from the body request, not from the path. So we need to use another annotation in this case, request body. Similar situation we have for the put mapping. Put stands for updating the record. We create update book method with book argument, which we annotate as request body, plus annotate the whole method with put mapping annotation. Is another one that stands for REST put request type. The method's body will be similar, but first make sure that the record for given ID exists in the database. If not, throw on an exception. Now we are able to update the entry. Last but not least, delete. Delete is pretty straightforward because we don't need to return the response event. So void delete book method, which will accept the ID argument, annotated with delete mapping annotation with /id value, which is saying that this method will be available for delete request type on localhost/books/id address. First, we are checking if the record exists in the database. If yes, we are going to remove it. The whole controller is ready. Time for run the app and check if it's working. Up and running. Let's call the endpoints. First, try to get list of the books. Get request type to HTTP localhost 8080/books. The port 8080 is default for Spring Boot application. You can change it in the configuration. The result is empty because we don't have any book, so let's add some. Post request type to HTTP localhost 8080/books with header content type application JSON, which tells to the application that we are going to send JSON as the request body. In the request body, let's define title and the author of the book. Execute the request. As you can see in the result, the created entity has been returned, so we can be sure that it's been saved in the database. Alright, we can verify if it's in the database for sure. Let's call /books endpoint once again. Looks fine, it's there. As for the function, we just called getAll method in the controller. There is one more thing we can verify on the fly, getting the book by ID. Do you remember the path pattern? We just need to put the ID to the address after the /. So localhost/books/id. And we have the response, the HTTP code 200 and the body. Awesome. Now, time for a little bit harder part. We need to update the record. Intentionally, I left some bug because I want to show you how to debug the application. So let's create another request. Put type to the localhost 8080/books/1 with changed body. We changed the author. Run it and seems like it's working. But focus on the returned ID. It's 2 instead of 1, which we wanted to update. Why? Let's get back to the controller. First thing is to put the breakpoint in the first line of the update book method. Breakpoint is the place where application will pause the execution in order to let us check what's what. We need to stop the application from normal run and run it in the debug mode. Usually it's a button with a bug icon. Once again, we are calling the endpoint by execution the previous request and the application stopped on the breakpoint we just added. In the debug tool window, we can investigate the variables and the parameters values. What can we understand from it? Let's expand the book parameter value. We can see that the ID is null. It's true because we didn't specify the value in the request body, which is provided the ID in the path. How we can fix it? After the if statement, Just pass the ID from the request to the book instance from the request body. Let's deactivate the endpoint, terminate the application debug mode, and run it again in the normal mode. Now let's call the endpoints again. Because we stopped the application, we need to provide books one more time. Why? As I said at the beginning, when we were defining the build.gradle file, H2 database operates in the memory. That means it's good for our development and test purposes, and it clears every application run. Anyway, let's just add the books, check if it's being saved, and if it's yes, the book will have the ID 1, so we can try to update the record once again. As we could expect, everything works fine. The author has been updated, the record has ID equals still 1, so it's working. Let's just verify it by finding the book by ID. Yep, all good. Nice. The last method we want to test is the delete one. So, delete request to the localhost 8080/books/1. Run it. HTTP 200 response means that the execution ends with the success. In order to verify, try to get book by ID. It ends with not found response because the record is not being in the database anymore. That's it for the first part. We covered half of the whole topic. We learned what is the framework, what is the difference between the Spring Framework and Spring Boot. We also fulfilled the goals. We did go through the application init, we implemented data access layer by defining entity and the repository, and we created the controller. As an extra point, we learned how to debug the application. In the next part, we will add the service layer and the business exception. As for now, thanks for watching and don't forget to hit the subscribe button. See you soon!